Okay, so question 3.3 says determine the equation of the axis of symmetry in the form y is equal to mx plus c. The axis of symmetry is not your asymptotes. Rather, it's this line here that passes through the point where the asymptotes intersect there at 45 degrees and goes through the graph. Where if you reflect that side and that side, it's perfectly identical. This is the axis of symmetry. All right. So we need to
Yeah.
determine that equation in the form mx plus c. So usually to determine the equation of a line, we need 2 points, right? On that line.
Yeah.
Let's look for the 2 points that we do have, right? Our 2 points can be where the asymptotes meet, and that point is 3 minus 1, right? And can we use D and 4 over 1? I mean D, which is 4 and 1. Um, I'm trying to think now. With a
Okay.
normal hyperbola, where the axes are the, it usually passes through 1 and 1. So with this one, uh, mm, I'm trying to think now. I'm trying to remember. It says M is negative as well.
Yeah. It's less than 0.
But why? Because this is a positive. This is a positive. Okay, so then they want this one. They want this one. Where if you reflect that, it would be identical as well. So if it passes through this point, okay, there we go. Okay, okay. So the thing is, we know we don't need 2 points. We don't need 2 points. We need our
Okay.
1 point we know, which is 3 and negative 1. And we know that the M will always be this will always be 45 degrees. So it's always either 1 or minus 1. So if M is negative, then they want M is equal to minus 1, right?
Yeah.
So with that in mind, we have Y is equal to negative X plus C. And to solve for C, we substitute our points. So we're gonna have minus 1 is equal to negative 3 plus C. All right, that's gonna give us minus 1 plus 3, that's 2. C is equal to 2. So therefore, our equation is Y is equal to negative X plus 2. All right, do you see how we got that? So it's important to
Yeah.
read. I almost missed this. All right, because there are two axes of symmetry. If you reflect it over this line, it will be identical, like they'll be folded in half. But also, if you reflect it over this line, it will also be identical. So if they specify which axis of symmetry they want, then then give them that one specifically where the gradient is negative. All right.
Yeah.
Okay. Next one, 3.4. I'm going to stop recording here. For
Okay.
the sake of the recording, let me just add this. All right, this is for Lifatsi's sake. Lifatsi dog, remember when we're covering our exponential graphs, we had this, and I told you that the decreasing exponential graph looks like of the equation a is or y rather y is equal to a to the power x over something, right? That is incorrect. That is my mistake. So actually, the general formula of the exponential graph is y is equal to a b to the x, where a determines your y-intercept. All right, this is your y-intercept. Okay, and then b determines the steepness of the graph. And the decreasing exponential graph looks like this. Y is equal to, I'm just gonna make A1. So it's gonna be when the B is a fraction. that's the decreasing exponential graph. That's when it decreases like this. All right, so that's just something to note there. Even with the general formulas, y is equal to 2 times 4 to the power x, all right, where a is 2, okay, and 4 is b. That is a positive graph, but the x-intercept is at 2. It's at 2, right? Because if I gave you, for example, if I substituted 0 into this, 4 to the power 0, right? That gives me 1. So that's 2 times 1. So my y-intercept will be at 2, and it's increasing. It's positive and it's increasing. So it's going to look like that instead. All right, so that's just for Lifati's sake, because I did give him the wrong information when we're dealing with these things yesterday. And also it's important that you take in how we solve question 3.3, because we solved question 3.3 with these, considering these the axis of symmetry, which is also incorrect. All right, so I'm gonna stop the recording here then.